In this puzzle, 3 circles are inscribed in the overlapping regions of a semicircle and quarter circle, the latter on the boundary of the former. B is the radius of the semicircle. A, codependent with B, is the radius of the quarter circle. The puzzle asks for the ratio of the radii of the larger circle to the smaller circles when both smaller circles are of equal size, or what is R3 over R1 when R1 and R2 are both equal. For this puzzle, we are adopting the problem-solving method of reconstruction to get a good understanding of geometry, gain useful insights, and arrive at a satisfactory solution. To begin, we set B to the unit value 1. This makes calculation easier. We can think of being able to scale, or alter, A, in order to discover a value where both R1 and R2 become equal. We can calculate a value for R1, which is a function of A and B. Using the Pythagorean theorem, it is possible to combine expressions in A and B, and then solve for R1, to arrive at a formula. We can do the same for R2. Now that we have 2 expressions for both small circle radii, both in terms of A and B, we can set them equal to each other and solve for A. This formula for A makes the value that is needed to make the 2 small circles equal. As you can see, its only dependency is B. However, as we initially set B to 1, a result for A is easier to calculate as B in the formula is used as a lone multiplier, and so could be eliminated. Plugging this value for A back into our original equations for either R1 or R2, we obtain the value of equal radii. To recap, we know what value of A is needed to make the 2 smaller circles equal size. Our penultimate step is to calculate R3. Again, using the method from earlier, we trace 2 lines from the center of both quarter and semicircles, perpendicular to the points of tangency on the boundaries. We find one length, expressed in terms of A, and the same length, expressed in terms of B, and solve for R3. Having values for both B and A, we calculate R3. The ratio of R3 to either smaller circle is easily calculated.